So I'll go if you want. I'm a PhD student in the School of Informatics. I'm going to try and give you kind of the computer science point of view on this type of thing and hopefully get out of the room alive at the end of it. So I'm talking mainly today about text mining. And text mining is obviously important to know if you want to do text mining, use text mining tools. Also important if you wanted to collaborate with people in the informatics department and use text mining on the type of data you have. It's also important to know because a lot of you are going to use digital humanities tools or processing of data, or even a lot of the search engines do have text mining software underneath. So it's almost like the thing you shouldn't know if you're eating sausages. You should know what's happening because there's a lot of assumptions that are made. There's a lot of things that are swept under the carpet. So I think it's quite good to know what kind of thing happens. Right, so first off, I'll talk a bit about what text mining is, and then I'll talk briefly about a project that we did that used text mining. This was with some environmental historians. So kind of how the collaboration, how the conversation happened between us and them. And that was a very difficult thing to get started because we came at things from a very different point of view. We had a very different language, and it took us quite a long time to actually work out how the other one does research. And that was quite a challenging task. Then I'm going to talk quickly if I get there, because I've got 30 slides and everyone else seems to have had about 5, so we might not reach that point. I think I've been a bit over-ambitious. We'll look at OCR errors. So this is one of the most difficult things in working with digitized data, especially data that is reasonably old or data that has been scanned quite a long time ago. So OCR, optical character recognition. So it's when you take a picture of a piece of paper, that paper has text on. OCR is what you run across it to get the words out, and it doesn't necessarily work very well. So when you're working with that kind of data, it's very difficult to get good results with things like text mining. So text mining, so you'll probably hear lots of fashionable terms like big data, data analytics, and that all boils down to data mining and text mining. So today we're going to talk about text mining. So this is processing text. And it's using lots of different techniques to abstract the meaning out of that text, to try and apply some kind of structure to that text so that then we can manipulate it digitally and get stuff out of that. It's particularly the thing with doing this kind of analysis. Anything a human can do, a computer can do really badly. So where we really win is we can do lots and lots of stuff. We can process lots and lots of data. But if you can pay some grad students to do it and they can do it, they're going to do it better. But if you've got too much data, that's when you have to turn towards things like text mining to try and get information out of that. And to reiterate, we're here as a starting off point. We don't want to take over the kind of scholarship that you're doing. It's a starting point, almost to filter the data that you have. So then you can focus on data you wouldn't necessarily have looked at, text and documents you wouldn't necessarily have originally looked at. So what can you do text mining on? So obviously you can do it on stuff that's born digital. So things like blogs, HTML, that kind of thing is very easy to process because that's been typed in. Then we've got the stuff that's been digitized. So things like journal articles. Most of those, even though they were typed originally, the originals were lost. And most of the time when you get them in online archives, their digital images have been taken of those pieces of paper and then they've been put into these online archives. So we've got things like metadata. So if you don't necessarily have the full thing digitized, you can still text mine the metadata. So you could have, so one example of where we've done this is an archive of plant specimens. So they actually have really detailed metadata describing what the plant is and where they're from. And you can actually do text mining on that, even though it's quite small amounts of data. If you have lots and lots and lots of them, it can still be a very useful thing to do. And then you've got kind of other things. So obviously anything you can turn into text, you can then do text mining. So the type of things that we have to do when we're text mining. I'm going to talk about named entity recognition, grounding, and relationship extraction in more detail, because that's what we've used in the trading consequences project that I'm kind of going to use to illustrate text mining. I'm not going to talk so much about clustering and topic modelling and sentiment analysis, but they're things that are really fashionable at the moment. So working out people's opinion on things is sentiment analysis. When people talk about things on Twitter, do they like it or not? So a lot of companies are very interested in doing that kind of thing. So and we've got clustering. Topic modelling is so fashionable. Everyone's doing topic modelling on everything. So it's trying to discover group things together. So you have lots of documents in a library, and they've been archived by a librarian, and they say what different topics they're in. But actually, if you run topic modelling across that data, you'll find out that there's lots more stuff that's in there that you don't. It's on more topics than the librarian thought it was, so it's different ways of classifying that. So, named entity recognition. So this is basically, it's looking for people, places, organisations, things that are proper nouns a lot of the time. Is we will use rules for searching for those things. Also, things that are of interest like dates, amounts of things, anything that you can devise a rule for that specifies that particular word or phrase in the text, then you can find it. Say a word like Paris in your text, and you need to work out whether that means Paris, Texas, whether it means Paris, France, whether it means Paris, Hilton. And then you want to kind of ground that to something. So you're linking it almost to a definition of that term. So the way we do that is with a location, we'll link it to a gazetteer, so like a collection of geographic names. Or with a person, quite often we'll link it to their Wikipedia description. Another example of that is Victoria. So the number of places that are called Victoria in the world, there's a huge number. And then you've also got Queen Victoria. So working out, you use the context within that text to work out which one of those it means, and you attach it to that canonical version. You say, this is about Queen Victoria, or this is about Paris Hilton. Once we've done that, we can then start to tie different things together. So we can use whereabouts they are in the text to link them together. So we can say if the person that we find in something is, say, an author of a book, or in the example that I'll be showing later, if a commodity has been traded to and from different locations. And the kind of relationship extraction, this is a version of someone doing it by hand. So the way we do this is we get a lot of humans to do this first. We look at what they're doing and we try and model that by computer. So you can see this is where a human is marking it up. So we've got by Thomas, son of Joyce, is that? Goldsmith and citizen of York. So we've got Joyce is a person, Thomas is a person, Goldsmith is an occupation, and York is a place. So we get humans to do that, and then we find rules so we can do that automatically. Once, this is quite a difficult slide to see, I now discover. So once you've found these different things, you can start linking them together. And once you've done that, you can create maps of what's going on in different sets of documents. So we can extract stuff and then link things together. So we've got Thomas is a person, he's the son of another person, and oh no! That's fine. And we can start building these webs from documents, and these are lots of different relationships all mapped together. Quick visualization I'll skip past because we're probably really over time. So, Trading Consequences is a 2-year project, and it was part of a JISC initiative, a Digging into Data initiative. And the rules of the project, but you had to have partners on either side of the Atlantic. So have some in the UK and some in the States or in Canada. So our group was made up of us, Informatics, York, which is in Toronto, I think, Saskatchewan, which is also in Canada, and then we've got Adina, which is down the road here, and we've got the University of St Andrews, and they did the visualization. So the people that are in Canada are the environmental historians. What they wanted to know was they wanted to extract from text different commodities that were traded around the world. So the different commodities that are traded at different times can tell you a lot about what was going on in the world at the time. So we were looking at 19th century stuff. So I think we've got, we had a nice example. So an example of this is, say, cinchona bark was used to make, quinine. So that can tell you a lot about the British Empire because of where it was grown and traded and shipped around the world. It can tell you where the British Empire was because that's what people were using to treat malaria at the time. So the aim of the project was to kind of look at these big data sets and see what we could extract from it, and to experiment with working with this kind of group, with kind of the cross-collaboration. The cross-collaboration as in across the Atlantic, but also between different types of scholars. And we wanted to help the historians do research in a different way. So as I said, what we're looking at is big data sets. So we're trying to gather together as much as possible to try and extract information from that. So these are the sets that we looked at. So House of Commons, I think it was Foreign Office papers were mentioned earlier. House of Commons papers, Early Canada Online, very important to the Canadians obviously. Director letters of Q. So that was very important because a lot of commodities, when they're traded around the world, they used to bring back specimen types to then grow in the big botanic centres, so in Edinburgh or in Kew. Also important to say about these kind of data sets is that you can't just go to your library and get them. You can't just download them off the internet. You need special licenses to process this data. If you start trying to do it without those licenses, you probably find lots of lawyers will send you nasty letters. And it's very long-winded to get the permissions to do this. So each of these archives had already agreed to work with the different universities through the project funding, but it still took up to 2 years in one case to actually get the agreement in place to use the data. So 10 million document pages is what we end up processing. That was 7 million word tokens, and that took about 8 days to run through the automatic processing, which doesn't sound like a very long time, but when the environmental historians say, oh, well, maybe we should just look at this as well, and then it's 8 days processing again. Right, so here's the example I was saying before, the cassia bark. So it's an example sentence, the type of thing that we got in the data that we had. So we have Padang, which is exported 1871. We have the amount that's exported, and where it's sent. Oh, Padang is where it was exported from, cassia bark, and it's going to America. So we identified that these words are in the data, and then we identified that there's a relationship. So we have kind of a to and a from relationship there. So the next thing we had to do was the grounding. So we had to define what our commodities were. So we asked the environmental historians to provide us with the data for this, and they sent us this kind of commodity lexicon reference. So these were custom records that we used, and we asked them to go through this set, and we used that kind of as seed data to extract the terms. So we defined a commodity as something that was lightly processed. So ammunition wasn't necessarily lightly processed, but things like goats and lambs and swine and hogs were. And so from the kind of the seed lexicon that we took from there, we ended up with an extended set of things that we added, plus the pluralization and things like that. These were the terms that came out. So a lot of these were things, this is the terms that came out of the text mining. So a lot of these weren't useful at all. So our top term that came out was papers. Clearly papers is not paper that's being traded around the world. It's probably the papers of, you know, someone's archive, or this is the papers of something. Train, that's not a lightly processed good, so that's removed. And to produce or produce, it probably isn't looking at it in the way we would want to. So the OCR problem to round off with. This is an OCR version of a piece of text. This is a good OCR version of a piece of text. And whenever you're searching on a search engine, this is the kind of stuff that's behind it. And the historians were horrified at the amount of stuff that they were missing in archives because of the bad OCR. They just hadn't realised that that was going to be the case. But when you see the information that's underneath, this is the kind of thing you get. That's bad OCR. It's just completely illegible. This OCR is from something that was digitised upside down, and that's in the archive, and no one picks up on it because it's all done automatically, and a lot of things are done by Google or they're done by someone else, and they're all shipped off and they're done, and you end up with that kind of thing back, and you can't quality control check that amount of data until someone starts processing it, and it's clearly nasty, nasty stuff. I've got some examples, but I'll skip through those because we don't have much time. We ended up throwing away a significant amount of the data. So our threshold was actually very low. We only threw away the really illegible stuff, and we tried to fix the stuff that was there. So there's things that are common problems that you'll find. So we had lime seemed to be this commodity that was traded a huge amount of times. And looking at the text, you finally work out that actually it's not lime, it's time. And that's not a commodity. It's this tiny OCR error that causes a huge amount of problems. And there's lots of those. But you can fix those, is the good point. Yeah, I'll leave it there.
Fantastic. One or two specific questions? Oh, no.
It's more a comment. I totally liked your presentation and very fascinating stuff. And I was myself struggling with the OCR problem. That's why I did not do a cohort analysis on my data. But I think my comment would be that you said it in the beginning. It's so important to not only understand these errors that are underlying your data, but also the algorithms themselves. Because now you haven't talked about the algorithms, but there are differences in these algorithms, and they produce different outputs, and you really have to know what they are doing, at least to a certain extent, to understand how you would then, on top, on the basis of the result, interpret that for your research question.
And the problem is, if you're using this data, it's probably used one of several algorithms, and you don't know which one it is. Yeah. And there's algorithms that work really well on 19th century text. The chances are that wasn't used on the data that you're working with. So a lot of the time you don't know. I mean, if you can get the data from multiple sources and kind of cross-check, that's the best thing you can do. Then you can find if it's been done by several different algorithms, and then you can take a mix between them. But it's one of those, when you're dealing with huge volumes of data, sometimes you have to deal with that kind of issue. But that's the kind of thing that we found the environmental historians were very unhappy.
No, I just mean that you really know, like, for example, there are thousands of different clustering algorithms, and the question is really, which one am I using and why, and what does the result, because otherwise people who are not into the algorithms might just use a tool that they find online, and there's some output, and then they somehow interpret that, but they have no meaningful interpretation because they don't know what the algorithm actually does. I just want to stress that it's really, really important.
Shall we open up to general? Yeah, let's open up to a general floor. Sorry, I'm just quite conscious of time. But yeah.
Thank you very much for the presentation. I wanted to ask, in trying to form a thematic, but you were interested in products that were being traded. Say, for example, one wanted to know about the issue of teams that were being researched or something across the globe. How would one use these vis-a-vis the issue of online data, online that document everywhere, and the issue of ethics?
Ethics is a massive, horrible issue for people working with this kind of data. It's not even, the laws haven't even been set down properly, particularly because I work a lot with social media data. The laws aren't even set down properly on how to deal with stuff that's born digital. So we have a lot of problems working with copyright data, and that's an issue with the old data. But now, yes, it's ethical issues, so yeah, it's a huge problem on copyright.
So one cannot be able to say you're using that in your PhD thesis because it's already a problem at the end of the day of how you got the data initially.
You can still use it, but you just have to be very careful and bear in mind that laws are being written as you're working with the data. So, like say if you're using Twitter data, Twitter have their own rules. So you do what they ask you to do, but also keep an eye on kind of the ethical standards that are expected if you were using data from real people, and then worry about kind of the laws that are being written as well. It's a huge market.
No, because it's, for me, I'm using InVivo, and with Encapture, you can bring in Facebook feeds, you can bring Twitter feeds, you can bring all the blog and all the stuff. Now, and those things are not yours; they are other people's, comments and things like that. And how do you play safe? Because it's comments in the open domain. Somebody has made comments about a particular issue. And how do you play safe when you have so-called mined the person's comments, and you've used the thesis, and I just want to be double sure that one is that I'm safe what to do.
Yeah, I can't can't understand. I mean, I'm using it in my work. It's going to be in my thesis, and I try and anonymise it, but actually that's pointless because you could just throw it in Google and be able to work out who it is. But yeah, I guess you can feel safe in the fact that there is a lot of published work using that data. So
If you say, follow
yeah.
Thank you.
Let's say thank you, Claire. More general.